I'm so excited. We're starting a new chapter. Polynomial functions. I love polynomial functions. I especially love factoring. I gave you that little test that, remember, doesn't count towards your grade, but that's factoring, and I'm excited to do that. And this chapter, since it's so long, we're actually going to cut it in half. So we're going to cover graphing polynomials, adding, subtracting, multiplying polynomials, dividing polynomials, and factoring polynomials, all in this first section. We'll have a test, and then we'll finish it off and have another test. So I'm excited to get this started. Okay, first of all, 3.1, graphing polynomials. The reason that I have a picture of a train here is because polynomials remind me of a train, and I'll show you that in a minute, why that's the case. Okay, so just a little bit of vocabulary. A polynomial is an expression which is the sum of the terms of the form a times x to the n power. What? I know. It's like, what the heck are you talking about? Oh, I forgot, where n is a non-negative integer. So a polynomial function looks like that, and it looks like a bunch of gibberish, doesn't it? Well, this is the actual definition of a polynomial. It's so much easier to show you with examples. So let's just look at a couple of other vocabulary words, and I'll show you an example. So first of all, the leading coefficient is the number that's right here out in the front, and the degree is the highest exponent, okay? And when something's written in standard form, it's when the terms of a polynomial are written in descending order of exponents from left to right, and it says it's shown as above, but let me just give you an example. Let's say I have x to the 5th minus 4x to the 4th plus x to the 3rd. Maybe we skip x squared, minus 3x plus 6. This is a polynomial. Okay, each of the exponents, this would have a 1. We don't usually put a 1 there, but this would be x to the first power. Each one of these exponents is a positive integer, okay, non-zero. And so, and the reason it reminds me of a train is because each one of these things is a term. This is a negative, this would be like a plus negative 4x. This would be plus a negative 3x. And all of these terms are divided by plus signs. So to me, again, I know it's really goofy. Okay, here's my wonderful artistic skills. Okay, but it just reminds me of a train. It's a polynomial train. Okay, and in this case, the leading coefficient, it's the number, it's the coefficient that goes along with the term with the biggest exponent. In this case, it's my invisible 1. So 1 is the leading coefficient, and the degree of this polynomial is 5 because it's the largest exponent in the polynomial. And the way that I remember what a degree is, you know, like if it's 80 degrees, we have, it's like a little circle that's like an exponent. So the degree is the highest exponent in the polynomial. All right, so here's just a few more vocabulary words. These are the types of polynomials that we'll be studying. And so I don't think they'll get any, if they get bigger than this, then we don't really know the name of it for this class. So, so if we have a constant, that's something like f of x equals 6. That's a constant function. Okay, linear is when the degree of the polynomial is 1. So we could write that like 2x to the first power. Okay, quadratic when the degree of the polynomial is 2. You guys know these. Okay, and we could say x squared plus x minus 3 or something. Okay, cubic is when the degree of the polynomial is 3. So f of x equals maybe 3x plus 7 or something like that. And quartic, that's a word that we don't use very much, but quartic is when the degree of the polynomial is 4. And I have C desmos on here, but I'm not going to pull that up right now. But that would be f of x equals 4x to the 4th minus 3x squared plus 2 or something like that. Okay, and these are all types of polynomials. So when they ask for a type, this is what they're talking about. Okay, so let's look at how we use these vocabulary words. Okay, so decide whether each function is a polynomial to even start with. If so, write it in standard form and state its degree, type, and leading coefficient. So here's our first one. We have negative 2x cubed plus 5x plus 8. It's in standard form because my exponents are in descending order. So my highest exponent is 3, this one's 1. So my degree, remember, that tells me my degree is the highest exponent. So my degree is 3. And when my degree is 3, the type is cubic. And the leading coefficient, I just have LC here. The leading coefficient is the number that's buddies with the, well, it's the number, it's the coefficient of the term with the highest degree. It's a lot easier to say, it's this one, okay? So it's negative 2, all right? It's the number that goes along with the exponent, the variable with the exponent with the highest degree. Okay. Degree, let's look. First of all, is it in standard form? It's not, okay, because I have x to the 4th right here. That should come first, because it's my highest exponent, minus 0.8x cubed minus 12. So my degree, again, highest exponent is 4. That makes this quartic. And my leading coefficient then is the square root of 2. Finally, I have negative x squared plus 7x to the negative 1st power plus 4x. Okay, this is not a polynomial. Not a polynomial. And why is it not a polynomial? Becky? Just kidding, I don't have a student named Becky, but it really bothers me that no one's here. Okay, not a polynomial. Why? Because I have this exponent right here. This exponent is negative 1, and I can't have any I can't have any negative exponents. Okay, they have to be integers from 0 on up. And you ask about, well, how something, you know, if it has a 0 exponent, x to the 0 power is 1. So we don't typically talk about, you know, x being to the 0 power because we just don't throw an x at all. Okay, I hope that wasn't too confusing, the whole x to the 0 power thing. All right, that's just not something you need to worry about too much. All right, so I'm out of time for this video. We'll move on in the next video.